Now it is your turn to rationalize some denominators. If you have not tried these examples already, please return to your lecture notes, complete these on your own first, then return to the videos to check your work. In part A, we have root 11 over root 7. To rationalize the denominator means I need to figure out what I'm going to multiply that denominator by to turn it into a square root of a perfect square. Well, I know 7 times 7 is 49, which makes 49 a perfect square. So if I can turn that denominator into the square root of 49, the square root of 49 will simplify down to a clean 7, and we'll have rationalized the denominator. So backtracking, I need to figure out, what am I going to multiply root 7 by to turn it into root 49? Well, root 7 times root 7 is root 49. But as with all fractions, if I multiply the denominator by root 7, I need to multiply the numerator also by root 7. Up in the numerator, root 11 times root 7 becomes the square root of 11 times 7, or the square root of 77. So by multiplying by root 7 over root 7, we get root 77 over root 49. The root 49 in the denominator cleans up to make 7, and root 77 up in the numerator does not simplify. There is no perfect square that divides into 77. So we can rewrite the original expression in part A as root 77 over 7, and its denominator has now been rationalized. In part B, we have 6 over root 8. We will approach this two different ways. The first way will be to simply do what we just did. I'm going to multiply root 8 in the denominator by another root 8 in the denominator, which will give me the square root of 64 in the denominator, and root 64 in the denominator simplifies down to 8. But if I multiply the denominator by root 8, I must multiply the numerator by root 8. So 6 times the square root of 8 is 6 root 8. But the catch here is that root 8 does simplify. Root 8 is the same thing as root 4 times the square root of 2. The reason we need to go this extra step is we do need to simplify radicals anytime we can. So in the numerator we have 6 times root 4 times root 2. Well, that root 4 simplifies to make 2, so we really have 6 times 2 times root 2, all over 8. Well, 6 times 2 is 12, so we have 12 root 2 over 8. But now we can simplify and reduce the 12 and the 18. Because the 12 is connected to the rest of the numerator with multiplication, we can cancel out a common factor of 4 from the 12 and the 8, leaving us with 3 and 2, or a simplified version of 3 root 2 all over 2. Again, that was one option. A second option we could have used on part B was not to just multiply by whatever the radical was in the denominator to begin with. So going back to the beginning, we started with 6 over square root of 8. The original question we had asked was, what do I need to multiply that root 8 by to turn it into the square root of a perfect square? There is another multiple of 8 that is also a perfect square, but smaller than 64. 16 is a perfect square. If I could turn the denominator into the square root of 16, the square root of 16 will simplify to make 4, and I will have rationalized my denominator. So I need to ask myself, 8 times what is 16? Well, 8 times 2 is 16. So if I instead multiply my original expression not by root 8 over root 8, but instead by root 2 over root 2, that will still rationalize my denominator. The advantage in this approach is I have less simplifying to do in the end. So multiplying 6 over root 8 by root 2 over root 2 gives us 6 root 2 over root 16. The root 16 in the denominator does simplify to make 4, and 6 root 2 doesn't simplify at all. But the overall expression of 6 root 2 over 4 does simplify. Again, because 6 is connected in the numerator by multiplication, and 6 and 4 have a common factor, we can cancel that common factor of 2 out of the 6 and the 4, and we'll arrive at the same answer we already had, 3 root 2 all over 2. Again, the advantage on the second approach is I had less simplifying to do. You will individually have to decide for yourself which approach you like better.